So welcome to NXCAM 20-minute Tech Tips. Today's demo is on the benefits of using a manufacturing setup and how to create one. The demo is going to last approximately 20 minutes, and then we'll keep the line open for Q&A for about another 20 minutes or so. So with that, I'd like to hand the session over to Phil, and he's going to be doing our demonstration.
Hi, thank you, Aaron. My name is Phil Malko from Siemens PLM. Today I'd like to spend 20 minutes or so to show you the advantages of a manufacturing setup and how to create one. Benefits of a manufacturing setup allow you to virtually simulate the physical setup, exposing the physical conflicts in terms of collisions with fixtures or machining components, and testing the machining limits or exceeding the machining limits during your program. It also illustrates the machining setup suitable for the part program to the machine operator, so they know exactly how to set the machine tool up. Inside the manufacturing setup, NX provides the ability to link the design model to the manufacturing workpiece such that you can simplify the workpiece suitable for your machining processes in the setup, such as removing holes from the part or slots and exposing nice clean surfaces for surface machining. If an engineering change takes place on the design model, the fact that our workpiece is associatively linked back to the design model, it automatically updates to reflect that engineering change. And at that point we can do an impact analysis to find out if we've over-machined the part due to the engineering change, or if we still have excess material that we can machine away. Of course, if we've over-machined the part, we can then determine how much over-machining we've done and decide whether or not the part can be welded up, or do we need to create an insert or start off with another blank piece of material. The level of detail for your setup is determined by the programmer and can be as simple as just a part model or as complex as needed. NX provides the capability to model a detailed setup quickly and easily for reliable machine simulation and error checking. So with that, I'd like to go into NX. So I need to share my desktop. All right. Can everybody see my desktop? Aaron, can you confirm for me, please?
Yes, I can see it, no problem.
Good, thank you. So let's open up a simple part we'll start off with. And just a quick overview of some of the capabilities in NXCAM. We have tools that we can go in and measure, say, the length of our model to get an understanding of the size of it. Or I can figure out what the height is, or in my case I'm really interested in what the width is because I want to use a vise to actually hold the part. So I'm working with a 135 millimeter wide part, and speaking of the vise, let's go to our NXCAM reuse library, and in here I have a series of hardware for setups. So you can see I have angle plates and parallels and tooling balls and all kinds of equipment here to aid my setup. So let's take the C-clamp as an example here. I'll just drag that into my environment. And you'll see that there's a reusable dialog that comes up that allows me to select from predetermined sizes. So I can select a larger clamp or maybe a deeper large clamp. And perhaps I want to set the opening of that clamp to some suitable dimension. So this is how we can use components to help enrich our manufacturing setup and simulate the true environment. In this case, I'm looking for a vise, so that'll be work holding and milling vices. Here I've got a couple milling vices. I'll just drag one in. And again, I can select from different sizes. So in this case, I'll go for a 10-inch milling vise, and I'll increase the jaw depth to say 3/8 of an inch, so you can see the jaw depths. I have a finger here to butt the workpiece up against. Maybe I want that on the right hand side. So you can see how quickly and easy it is to configure your fixturing based on the reuse library components. The jaw opening here should be 135 millimeters, and you'll notice that there's a value of 3 in there, which looks like I'm working with inches in terms of the vise, but my setup is actually a metric setup, so we have no problem mixing and matching dimensions within the setup. Just type a mm after the value, and NX will automatically convert it on the fly. So there I have my milling vise configured the way I want. And let's go ahead now and relate that milling vise to the part itself. So I'll spin my view around a little bit so that I can see it. Hopefully you see that dynamically enough on your session. And we'll use the NX assembly relationship tools to position my part against the jaws of the vise. So I simply select the face and of the part of the workpiece and the face of the fixture geometry, and NX automatically positions my part relative to that face. So there are different types of assembly constraints used to do that. I'm using the touch align. There's also tools to do concentric and parallel, perpendicular, or center something, or set it at an angle. So there's a rich suite of tools used to position your part. You may have noticed that I turned off the display of the vise that I pulled in and put my part onto the vise that was already in the setup. And I did that just for the sake of time. I actually have a Makino A66 machine tool in my setup. If I turn that on in the display, you'll see the full machine, my milling vise, and my part in the manufacturing setup. Change my display to turn off the true shading. So now you can actually see my part, my milling vise, which is mounted on the rotary table, which is an A and B, C axis, or sorry, B and C axis. On my Makino, you can see the axis direction on the Makino for X and Y, and Z being along the spindle. So at this point in time, I don't really need to see the entire setup for programming the part. I'll use this for checking the programs after I've checking the motion after I've created the program. So I can simply turn off the machine and the milling vise. So now I'm just looking at my workpiece. At this point in time, I'd like to start producing the toolpaths on the part. So I'll use a machining template to do that. And as I go through the template, the first thing I need to do is specify my machine coordinate system, origin. So we have a nice dynamic tool which allows me to simply drag and drop my MCS to where I want it. And in this particular case, I want it, actually before I do that, let me just cancel that for a second. I need to create an associative link between my design model and my workpiece. I haven't done that yet. So to do that, I have a chain link in which I will select the actual design body, and you'll see how it says associative here. So when I say OK, it produces an associative link inside of my setup file. What that means is that I can go in and I can actually simplify my part. So I'll use the synchronous modeling technology to say remove some faces. I square up my view by pressing F8 on the keyboard, which orients my view to the nearest orthogonal face. So if I say delete on that, they disappear. And at the same time, I can remove holes. And I have it set to 50 millimeter size. So if I do Control A on the keyboard, it selects all the holes that are less than or equal to 50. And when I say OK, they'll disappear. You'll notice that you'll see some line geometry still up on the screen here. That's because I'm still displaying the design part. If I turn that off, then I have nice clean faces for my machining. In fact, if I go to the wireframe view and turn the engineering or design part back on, you can see the geometry still exists in the design part, but it doesn't exist in my workpiece. So looking at the part navigator, you'll see the link that I created, and then these are the two synchronous modeling features that I use to simplify my workpiece. So later on down the road, if an engineering change takes place on the design model, it will reflect in my linked body, and then the synchronous modeling features will be replayed against the link body, and it will automatically update for me. At that point in time, I can do that, figure out if it's over-machined, under-machined, and then regenerate my toolpath as needed. So now that we have our part linked, let's go ahead then and start creating those toolpaths. So the first thing I need to do is what I was doing earlier, is create that MCS location. In this case, I want it to be the bottom corner of the part. And this is a nice user-friendly tool in terms that I can simply grab these drag handles and rotate the axis any way I want. And I could enter numbers in these fields here to get exact. It automatically aligns to the geometry I selected. So very quick and easy to do. The next thing I'd have to do then is identify the workpiece, or the part that's going to be machined, and then I would specify the blank size. So NXCam automatically gives me a blank size, which is the volumetric extent of my workpiece, and it provides capability for me to extend any of these faces in any direction. I could also put in specific values, or I could select from another piece of geometry if I had a casting, or I could use a faceted model. Sometimes customers get pre-machined parts that they're going to do continuous machining on. So they scan the part with a scanner, which produces a faceted body, and you can use that faceted body then as your blank geometry for machining, and that way you don't cut air where it's been machined already. If I had clamps that I wanted to identify for collision avoidance, I could identify those now. And I would specify the part material. In this case, I'll use P20 tool steel, which will help calculate the speeds and feeds for any manufacturing operations. Next, what I'll do is I'll specify the flat horizontal faces that could be machined with the end of an end mill. So I'll just interactively pick those. When I'm picking these, I could also use color selection or attributes. If I had attributes on those surfaces, I could automatically pick those through the attributes. Next step would be to identify any 3D faces that would be finished with a ball mill. Again, I'm going to press the F8 key on the keyboard, and that snaps my view to the nearest orthogonal orientation. So it makes it easy for me to pick my geometry. At this point, I could either generate my program, or if I want to do some sort of pencil tracing operations, I could identify the islands. In this case, we'll do pencil tracing around all of these fillets in those two islands here. So I'll just select those. And I'm selecting using a lasso type of selection option. By default, I think NX has a rectangular selection tool. The nice thing about the lasso is that I can quickly or easily navigate around geometry to identify exactly the geometry I want, whereas a rectangle just takes an area. So at this point in time, I'll hit the Generate Toolpath button, and it will compute the toolpaths along the geometry that I've created. Now these manufacturing templates are typically set up by a more experienced or expert user within your organization, and then a casual or new user of NXCam would use these templates or reuse these templates to quickly machine the less difficult parts, freeing up the expert user to create templates for more complex parts or work on more complex parts, whichever is required. So if I go to view the results of the template that I ran, so it's created the MCS, it's created my workpiece, and under my workpiece is all the machining operations that were created. At this point, I can go and have a look at the results of this machining. So I'll display just the current level so that I can clearly see exactly what's happening at each level, and I can pause at each level. This allows me to then to step forward level by level and see the results of that toolpath. At any point in time, I can click on any of these toolpath segments and look at my tool relative to my workpiece. In fact, NX provides me with the ability to create a section view of my workpiece, and I can snap to the origin of my tool and use the orientation tool to rotate my view to see what sort of clearances I have around my tool at any given orientation. very valuable in terms of understanding exactly what's going on around the tool at any point in time. Also, we have a dynamic verification tool which allows me to see the material being removed as the toolpath is replayed. Helps me understand how the part is being machined. Now this dynamic is a static view. We have a 3D dynamic which is actually a dynamic view. So as the tool is moving around and removing material, I can actually change the orientation of my view to see better what's going on. I can also use that section tool while this is taking place as well. So I can section my part and have a look at what's going on dynamically as it's running that toolpath simulation. Let me stop that at this point in time. And what I'm going to do is I'm going to suspend the animation, and I'm going to drive the toolpath to the end of the part. So let NXCam analyze the results of the machining operations so that I can see the state of my in-process workpiece at the end of all my machining. As it's doing that, you can see the current operation that it's processing. And these are all the operations that were in the machining templates that were set up. Okay, so there is my in-process workpiece in its state as the machining is completed. And to the naked eye, it looks great. But there's actually a tool within NXCam to analyze the results of the machining compared to the design model. And what it does is it presents me with a view of colors, a hierarchy of colors here that shows me or gives me an indication of material thickness left on the part based on the darker shade of color. And if it's red, it means it's been over machined. I can also poke locations on the part with my cursor and determine how much material is left at that point. So you can see that the flat faces are machined pretty close, but there's some dark area here which I'm not quite sure what's going on. So by picking that location, I can see the actual thickness of material at that point. Let me take that section tool that we have in NX to help understand what's going on at that point. With this section tool, I can navigate such that the cross-section is showing me the area that I'm interested in. And this curve that you see at the bottom here, let me zoom in a little closer, this is the actual design model edge. And this edge is the results of the IPW. So I'm starting to get an understanding of what's going on. It looks like the ball nose cutter that was used to cut this area is a bigger radius than the actual part geometry. While I'm here, let me show you some other tools in the section environment here. If I change the orientation so that I'm sectioning this way, if your part is really big and you want to take a closer look, but sometimes it's obscured by the other geometry within the part, instead of using one plane, I can use two parallel planes. So I can click on the other plane and then do a double section of my part, and now I can see that area of geometry that I'm just interested in. So it really helps me visualize and understand what's going on with my part. You can also set a box, which would be 4 planes, but in this at this point in time, I don't need to go into that. So I'll say OK to this and OK to that, and we'll turn off my section view. And what's going on here is I have this flow cut operation, which is being the tool selection was based on the size of these radiuses here. So that's a 3mm radius, and I'm using the geometric properties tool, which actually you can pull down from analysis and use the geometric properties. And you can customize your menu so that it's just a pop-up on your menu system, and that's what I've done. And the geometric properties then allows me then to dynamically move my cursor over geometry, and up in the window here it tells me what I'm actually looking at. So this says -3mm, so that's a 6mm, sorry, a 3mm radius in that corner. I'd use a 6mm ball, and over here that's a 2mm radius, so I need a 4mm ball to machine that. So the way I'll fix this is I'll copy this machining operation. So in NXCam I can say copy and paste. So that pastes, that gives me a duplication of this entire machining operation with all the details. Then I can go in and modify this specific machining operation. In this case, I can go and select a new tool. So let's go and look for tools within the NXCAM tooling library. This is the out-of-box tooling library. So every installation of NXCAM would have this, and you can add your own custom tools to this library as well. So I'm looking for 4 millimeters, and it shows me a 4 millimeter ball end mill in the library. I also have one in my setup, so I'm going to pick the ball end mill in my setup, and if I was to actually pick a point on the geometry, I can see what this tool looks like relative to my part geometry. So if I just pick on any piece of geometry, it will snap to the nearest point on the geometry. And of course, again, at this point in time, I could go in and I could say, let's take a section view, and this numeric dialog appears. Sometimes it's in your way. If you press the F3 button, it will disappear, and then it's not in your way anymore. And I'm rolling my mouse button to zoom in. I can pick on the center point of the tool and press F8 to make my view orthogonal, and I get a real clear view that that tool is now going to fit in that radius. So that's perfect. So we've got the tool. What we need to do now is specify just to machine that geometry that was under machine. So I'm going to specify the geometry as the workpiece, which is the entire part, and then I can specify the specific cut area that I want this tool path to operate on. So I'll pick on these two fillets and say OK and generate. So we've generated a tool path on those two fillets. Now NXCAM is a great tool for single part machining because you can generate tool paths very quickly, but it's also a great tool for high production parts, producing thousands and thousands, because we have the ability to microcontrol any of the motion of the tool. For instance, when the tool moves from this, cutting this fillet here, it moves up and over and then down to this fillet to start machining. And we call this between regions. This would be region 1 and region 2. So we can look at the rapid motion here, and between regions we can say traverse. Right now it's going up to the clearance plane, so we'll say at the lowest safe Z, or in Canada we say Z. And I can specify the radius relative to, or sorry, the distance relative to the tool size or a specific value. So I'll just leave it as 50% of the tool size. And also, as it's moving, I want to support high-speed machining, so I'm going to turn on the smoothing, and again I can say we'll use a smoothing radius of 50% of the tool size. If I say OK to that and generate, you'll see the results of that change. So now the tool is actually lifting just a little bit above the part and moving over to the other area and machining the second area. And as it lifts over, it's looking at the in-process workpiece to make sure that it's not colliding with anything. So now we've fixed that area, and if I look at the analysis of the part itself, you'll see that there's, I'm looking at draft analysis, and there's these walls have a bit of taper on them, both of them in the pocket here. So what I'd like to do is I'd like to use a 5-axis swarf cut type motion to machine that. So let's interactively create a machine toolpath, and in this case I want to use a swarf cut 5-axis. I'm going to use a long series 6mm ball cutter, and I want to machine the workpiece, and I'm going to use a finishing method which sets up my tolerances and speeds and feeds for me. And if I say OK, a dialog comes up where I can actually specify the geometry that I want to machine. In this case I'll just pick the floors of those pockets, and NXCAM will automatically find the angle of the wall, tip the tool axis over for me, and machine, swarf cut machine that area perfectly for me. All right, so the next step would be to actually simulate my toolpath here. So let's go and first of all we want to identify the part for the simulation. So I'll just do that by picking the part. And if I pick the the entire program, I can go into the simulation environment, and inside the simulation I can actually show the 3D material removal. So it'll put the material on the part itself. And I'm going to tell the simulation to actually simulate machine code. So it's actually going to post-process the generic motion to machine-specific code and display it up in this window here where it says NC Program. While I'm doing the simulation, I want to see the milling vise, and I want to see the body of the milling machine as well, just to see. I want to make sure everything is working as it should. So I can go ahead then and start the simulation. We can see the posted output being displayed in the NC Program area, and we see the motion of the machine tool, and we see the material being removed at the same time. These particular machining operations are simple 2.5 axis machining, so the B and C axis are stable. Let's stop it at this point. And what I'm going to do is I'm just going to select the last 2 machining operations in my program, and let's do a simulation on that. So the system is probably going to give me a message to say, you know, I'm colliding with the in-process workpiece because I'm not processing the entire toolpath, but that's okay at this point. So we got our tool change. There's that message I was talking about. I'll just say continue until reset. We can look closely, and we'll do a play at this point, and you can see the tool moving along those operations that I added. Changes tool, and then it does the swarf cut machining of the 5 axis. You can see B and C axis are moving simultaneously, as well as the X, Y, Z. So there's the other pocket that it's doing. Let's just speed that up a little bit. So full 5-axis simulation on my output. And the last couple things I'd want to do at this point in time would be to actually post-process the output. So I'll simply say OK to this. It automatically knows which post-processor to use because it's embedded in the machine. So there's my NC program. And lastly, what I'd like to do is create shop documentation so that the operator knows how to set the machine up. In this particular case, I don't need to have the machine tool displayed in here. So I'll just use the vise and the workpiece, and I'll create an HTML type shop documentation for milling. And that allows me to use Internet Explorer type tool to view these documents down on the shop floor. So it launches Internet Explorer, launches the documentation in Internet Explorer. I see my part in my fix ring. I see the tool list. I can go in and I look at the parameters of the tool to see how they should be set. I see my cutting sequences. I have the flat faces machining. Just move that over a little bit. And the flow cut single. And we have that 5-axis contour. So very complete process and fully verified in a manufacturing setup. At this point,